Okay, the first thing that we need to understand is whenever we have log of x to the base a is equals to log of y to the base a. So if I have base as same on both the sides with the log, we can also equate these values. So that means I can say x is equals to y. So if I need to equate these two things, I have to think about making the base to be same. So in order to do that, so I would do the change of base rule. So if I talk about this one, the left-hand side, I'll keep it as it is, which is log of x minus 2 to the base 2 is equals to, for the right-hand side, I would write it as log of x square minus 6x plus 12 to the base 2 divided by log of 4 to the base 2. The reason why we can write it like this is we have this change of base rule in log something like this. So if I have log of a to the base b, this thing can also be written as log of a to the base c over log of b to the base c, where c could be any value. So here I'm taking the c to be 2. So now the value of log of 4 to the base 2, so that log of 4 to the base 2 can also be written as log of 2 square to the base 2, and this 2 can come in the front of the log, so it's going to be 2 times log of 2 to the base 2, and the log of 2 to the base 2 is just 1, so that's why the result of this one is just going to be 2. So in that case, I will be having log of x minus 2 to the base 2 is equals to log of x square minus 6x plus 12 to the base 2 and entire thing divided by 2. If I take this 2 to the left hand side, so it's going to be 2 times log of x minus 2 to the base 2 is equals to log of x square minus 6x plus 12 to the base 2. So now if I want to take this coefficient inside the log, so that's going to become the power. So it's going to be log of x minus 2 whole square to the base 2 is equals to log of x square minus 6x plus 12 to the base 2. So now both the sides I have the same logs with the same bases. I can equate these things. So x minus 2 whole square would be same as this one. So if I also expand this x minus 2 whole square, so that's going to be x square minus 4x plus 4 is equals to x square minus 6x plus 12. I'll keep the 12 on the other side. So both the sides, x square and x square can get cancelled out. So I'll take the minus 6x to the left hand side and this positive 4 to the right hand side. So I'll be getting minus 4x plus 6x is equals to 12 minus 4. So in that case, I'll be getting 2x equals to 8. So that is the reason the value of x is 8 over 2, which is 4. And this is the right answer for part A. Now, if I talk about part B, so we are talking about x to the power of ln x is equals to e to the power of ln x whole square. So now what we are going to do here is, so now we also know this, e power ln x can be written as just x. So whenever we have e power ln x, so that's just going to be x. So now if I have e to the power of ln x whole cube, let us keep this thing in mind. And also what we are going to do it for this one is, we are going to apply ln on both the sides. When I apply ln on both the sides, so it's going to be ln of x to the power of ln x is equals to ln of e to the power of ln x whole cube. So now this, we also know this property, that is, if I have ln of m to the power of n, this can be written as n times ln m. So that's why this ln x, this is in the power of x, so that can come in the front. So it's going to be ln x multiplied by ln x. And here it would be ln x whole cube multiplied by ln e, and the value of ln e is going to be just 1. So this is going to be ln x whole square is equals to ln x whole cube. So from here, if I want to solve for x, so what I'll do is I'll take this ln of x squared to the other side. So we will be having ln x whole cube minus ln x whole square would be equals to 0. So from here, so if I take ln x whole square common out, so I'll be left with ln x minus 1. So whenever we have something like the product of two terms is equals to 0, so we can equate each terms to 0. So in that case, either we will be having this ln x to be equals to 0, or ln x minus 1 has to be equals to 0. So in that case, whenever we have ln x equals to 0, and if I want to make x the subject, x would be equals to e to the power of, so the base is going to be e. If there is no base for ln, so it's going to be e. So when this only ln goes to the other side, it will become e to the power of whatever we have it on the other side. It's going to be e power 0, so which is just going to be 1. Or when 1 goes to the other side, so it's going to be ln x equals to 1. Again, if there is no base, it's going to be e. So in that case, when you take this ln to the other side, so it's going to be e to the power of whatever we have it on the other side. So e power 1 is going to be 1 itself. So there are two possible answers for part B. One is either x could be 1 or x could be e. This is the right answer for the sum.